Okay, let's talk about one of the most truly mind-bending things in the entire universe, the black hole. It's like nature's ultimate magic trick, a place where all the rules of reality just, well, they seem to break down. We're going to separate the science fiction from the science fact and explore what we actually know, and, maybe more importantly, the profound mysteries that are still out there.
So, let me ask you this. What if I told you that there's a place out there in the cosmos where light itself can't escape?
A place so extreme, so bizarre, that time literally grinds to a halt.
And no, this isn't something out of a movie. This is real. Billions of these things exist right now, silently hanging out in the darkness, shaping the universe around them. All of this brings us to the one question that has been driving scientists crazy for decades. What actually happens inside a black hole? You might think you have an idea, but trust me, the truth is far, far stranger than you imagine.
All right, so let's start at the beginning and clear up a few things. We're diving into the universe's darkest secret, what a black hole really is.
You know, the picture most of us have in our heads is this kind of cosmic vacuum cleaner, just gobbling up everything in sight. But that's not really how it works. A black hole is actually an object that is so unbelievably dense, it creates a gravitational field so powerful that once you get too close, nothing gets out. And I mean nothing, not even light. And that boundary, that edge, it has a name, the event horizon. You can think of it as the ultimate point of no return. It's this invisible line in space that separates our universe from something truly unknowable.
To give you an idea of just how dense we're talking about, get this. If you could take our own sun, which is over 1 million times bigger than Earth, and squeeze all of that mass down, it would become a black hole just 3 kilometers across. Think about that. An entire star crushed down to the size of a small town. Now, this is where things get really weird. Because that incredible gravity doesn't just warp space, it actually warps time itself. Let's talk about gravity's strange effect on the clock. You see, according to Einstein's theory of general relativity, the stronger the gravity, the slower time passes. So let's imagine an astronaut, we'll call her Maya, and she's traveling towards a black hole. As she gets closer to the event horizon, we, watching her from way back here on Earth, would see her slow down. Her movements would stretch out until she looked like she was completely frozen in time, right at the edge. But here's the crazy part. For Maya, time would feel totally normal. She'd just sail right across that boundary without even noticing.
So, what happens after she crosses that invisible line? Now we're going past the event horizon and heading toward what some people call the point of infinity.
At the very heart of every single black hole, we believe there is a singularity. This is a single point where all of the black hole's mass is crushed down into a space of, well, infinite density. And right here, our understanding of physics, the very laws that run the universe, they stop working. This is where Einstein's big picture of gravity clashes head-on with the bizarre rules of the quantum world. And that leads us to maybe the single biggest mystery in all of physics, because nobody knows what a singularity actually is. I mean, could it be a wormhole that leads to another universe? Maybe a bridge to a totally different timeline? Or could it even be the seed from which a new universe is born? And these aren't just ideas for sci-fi movies. These are real, theoretical possibilities that physicists are debating right now. For a long, long time, scientists basically thought of black holes as these lonely, isolated objects. But then, a massive breakthrough showed us that they can interact in the most dramatic ways you can imagine. And it gave us a completely new way to see the universe. In 2015, everything changed. For the very first time, the LIGO Observatory detected something incredible: tiny ripples in the fabric of space-time itself. These gravitational waves were the cosmic echo of 2 black holes spiraling into each other and merging billions of light years away. I mean, this discovery kicked off a whole new era of astronomy. It wasn't just proof that black holes could collide, it basically gave us a brand new sense. For the first time, we could observe the invisible. Instead of just looking for light with telescopes, we can now listen to the vibrations of the cosmos. We can hear the universe's most violent events, things we could never, ever see. And all of this brings this giant cosmic mystery right into our own galactic backyard. It makes you wonder, could these things be tied not just to the end of things, but maybe to the beginning?
This number right here, 4 million, that's the estimated mass of Sagittarius A star, the supermassive black hole sitting at the center of our very own Milky Way galaxy. We're talking 4 million times the mass of our sun.
So, after all that, the time-bending gravity, the physics-breaking singularities, the universe-shaking collisions, let's circle back to our big question. What is a black hole, really?
I think the most important thing to remember is that a black hole isn't some cosmic monster. It's more like nature's most extreme laboratory. It's a place where gravity is so strong it literally warps time and bends space. A place where our fundamental understanding of reality just starts to get blurry around the edges.
Which leaves us with one last really provocative thought to chew on. What if black holes aren't the place where physics ends? What if they're actually the beginning? The key to a brand new, deeper understanding of our universe might just be hiding in those deep, dark shadows, just waiting for us to figure it out.